Math 1, second semester final review, Unit 6. All right, number 14. Yes or no, does the residual plot suggest that a linear model may be the best fit for the data? What we're looking for is randomness, and we're looking for about as many of the points above or below the x-axis. This is certainly not random. It looks like a parabola, so this is no. And B, okay, it looks pretty random. It's about as many above the x-axis as below. It's a very strong correlation, but yes, linear would work here. C, again, looks like a parabola, so this would be no. They're not random. There's some kind of pattern to them, and even though they do look about even top and bottom. Okay, here, randomness, about the same amount above as below. Looks like there's a little more above, but it is random and about equal, so this would be yes. Okay, moving up to number 15. For the following set of data, okay, create a histogram. For example, the number 45 under the first line means the bar to the left is the number from 40 to 45. 40 to 44. So from here to here is 40 to 44. And nice enough, these are all in order already for us. If they weren't, we'd have to put them in order first. So we can shade this guy up 1, 2, 3, because there are 3 data pieces less than 45. So now we're going 45 to 49, which looks like there's only 1. And now we're going 50 to 55, which again, it looks like 1. 55 to 60, looks like 1, 2, 3, 4. And then 60 to 65, 1, 2, 3, 4 again. And 65 to 70, 1, 2, 3. And 70 to 75, none. 80 to 85, it looks like there are 4. And there you go. Okay, using the same data, number 15, find the following and then create a box and whisker plot. Okay, so the minimum right here, 42. The maximum right over there, 83. The range, well, it's 83 minus 42, or 41. The median, okay, is the second quartile. So we basically find out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so the median would be right between 10 and 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be right here. So we have to average these two guys. So they're both 60, so 1 plus 3 is 4, divided by 2 is 62. So the median is 62. Okay, since it's even, it means all of these are in the lower half and all of those are in the upper half. So to find the first quartile, we take these first 10 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, we average these two, 52 and 56. Add those together is 108, divided by 2 is 54. And then the third quartile, 1, 2, 3, 4, 5, and 6, they're both 66. All right. This is true of every box and whisker plot. The percent of numbers in the inner quartile range, that's between these two data pieces, is always 50% of your data will always be in there. All right, so the first thing we do is we find our median, which is 62, which is right here, 61, 62. I'm going to put a little box right there. Our first quartile is at 54, right there. And our third is at 66, right here. This is our inner quartile range right here. 50% of your data will always be here. It's what we call our box. Your whiskers are just go out to the minimum and to the maximum, 83 right there. And there's your box and whisker plot. Pretty simple. All right, moving on. All right, number 17. Determine if the statement is true or false or can't be determined. 5 people spent more than $225 on groceries. Okay, well, 225 is right here, so 5 would be true. There's 5 right there. Oh, actually, yep, and 225 would be right here, so that is true. There are an equal number of people who spent 26 to 75 right here as who spent 176 to 225 right here. And that would not be true. 10 people spent 26 to 75. Looks like 15 people spent 176 to 225, so that would be false. Less than 20 people spent less than $100. Okay, well, let's see. Well, $100 is somewhere in here, so we really can't determine that. So we'll just be can't be determined. Okay, CD for can't determine. 45 people spent between 126 and 175. Well, 126 and 175 is 45 people. That's true. Only 20 people spent more than $175. Well, here's 175, so it looks like it's 15 plus 5 or 20. And that is true. All right, moving on to number 18. All right. So let's see here. From the scatter plot, does the data have a positive, negative, or no correlation? That is a positive correlation. Positive. Is the correlation coefficient closer to negative 9, negative 0.9, negative 0.090, or, well, it's right here. It's always the greatest it can be is 1, positive or negative 1, so it's 0.9. That's a very strong correlation. Using the coordinates of 440 and 850, find the equation of the trend line, plot the line. Okay, so we need slope. So first thing we do is we find the slope. So that's slope equals y2, which is 50, not 80, 50 minus 40 over 8 minus 4. So we end up with 10 over 4, or 2.5. That's our slope. Now, using point slope formula, we're going to say y minus, and we're just going to pick a point. So we'll go with 440, and so we'll go y minus 40 equals 2.5 times x minus 4. Now to put it in slope-intercept form, we go y minus 40 equals 2.5x, and 2.5 times 8 is 10, so minus 10. And then we add 40 to both sides, and we end up with y equals 2.5x plus 30. And that is our line of best fit. Okay, moving on. Complete the table to the left and find to the nearest tenth. Okay, what is the grand total of number of students who took the survey? Right there, 200. Looks like we need to fill in some blanks before we go any further. All right, so if 98 males were interviewed and 60 of them preferred watching in a stadium, that would mean 38 viewed watching it on TV. So if there were 88 people enjoyed watching it on TV and 38 of them were men, that means 50 of them had to be females. Okay, and again, if 200 were surveyed and 98 were men, it means 102 had to be females. And if 50 of those 102 females like to watch it on TV, it looks like 52 preferred watching it in the stadium, and 52 plus 60 is 112 people preferred watching in the stadium. Okay, now that we have that all filled out, we're ready to answer the rest of these questions. What is the marginal frequency of a student who chose TV? So marginal is on the edge, marginal, who chose to watch it on TV. Marginal frequency is 88. Okay. C, what is the marginal relative frequency of the students who chose TV? So marginal relative, that means it's a fraction. We're comparing two things. So that's 88 relative to 200. So that's 88 relative to 200. And now we're going to reduce. And just to remind you guys, these calculators are great for reducing. You go 88, enter, 200, hit enter, and you get a reduced fraction of 11/25. D, what is the joint frequency of students who were males who thought the best way to see a baseball game was in the stadium? The joint frequency, joint means it's one of these four. It's males who thought it was best to see the baseball game in the stadium. So males and stadium, 60. Now it's only a number because there's no relative. If you don't see relative, it's just a number and not a fraction. What is the joint relative frequency of students who were males who thought the best way to see the baseball game was at the stadium? So now it's males and stadium, but it's relative to the total, or 60 over 200. We don't need a calculator here. We'll cross off those zeros, and these are both even, so it is 3/10. Okay, last one. What is the conditional relative frequency that the person was female given that they prefer to watch the game in the stadium? So given that is where we think of our division bar. So it's actually females over stadium. So now all we care about is the people who wanted to watch it in the stadium, which is right here. Of those people who wanted to watch it in the stadium, of those 112 people who wanted to watch it in the stadium, how many of them were females? 52. So the conditional relative frequency of persons was female, given that they preferred watching the stadium, 52 over 112. And again, 52, there's that little button there, over 112, and reduce to 13/28. Always reduce. All right, almost done with these first two units. All right, state if the graph is uniform, symmetric, or skewed. All right, uniform, we're looking for flat across the top. That is definitely uniformed. Okay, B right here, that is definitely skewed to one side. C, yeah, it's a tough call there. I'm going to go with, does it look more like this or does it look more like that? I'm going to say it looks more skewed. I'm going with skewed. And this guy is definitely symmetrical. Or symmetric. All right, last one, number 21. The linear regression equation for a data set is y equals -1 or 2.5x plus 42, where x is the distance in feet a basketball player is from the basket and y is the number of baskets made. Use the equation to predict how many baskets a player will make from 7 feet. 15 feet, round to the nearest whole number. So the further somebody gets away from the basket, the fewer shots they're going to make. That's why it's negative. So we'll go y equals -2.5 times 7 plus 42. All right, and we can plug that right into our calculator. All right, -2.5 times 7 plus 42. Pretty simple. 24.5, we'll round that up to 25. Okay, and 15, so that's y equals -2.5 times 15 plus 42. So again, in the calculator, there's that negative button right there. Oops, can't see it right down there. -2.5 times 15 plus 42, and we get 4.5 or 5. Obviously, the further they are from the basket, the harder it is to make a shot. So at 15 feet, they make 5, and at 7 feet, they'd make 25. Okay, last question. In May, the auto company sold cars for $10,000, $12,000, $12,000, $12,000, $15,000, $17,000. In June, the auto company sold cars for this amount. the minimum for both sets of data is the same. Okay? Let's see here. What are we doing here? Okay, so the minimum in May was 10,000, and in June was 10,000. So the minimum for both sets of data is the same. True. The maximum for both sets of data is the same. Well, let's see. 17,000 and 34,000. Nope. False. The mode for both sets of data is the same. Well, the mode is what happens most often. In May, it was 12,000, and in June, it was 12,000. So that is true. The mean for both sets of data is the same. Well, let's see. Better go, we don't need the thousands. Just go 10, 22, 34, 46, 71, 88. Okay, 88 divided by 1, 2, 3, 4, 5, 6. So 14.7. Okay. And let's go 10, 22, 34, 46, 51, or excuse me, 61, 71, 78, 112 divided by 1, 2, 3, 4, 5, 6, 7. So 112 is 16. So no. 14.7 and 16, so that's false. The median for both sets of data is the same. Well, the median is the middle number, so 1, 2, 3, 4, 5, 6. So we have to average the middle two, which is 12,000. Let's see, 1, 2, 3, 4, 5, 6, 7. So the fourth piece of data, 1, 2, 3, 4. So that's 12,000. So that is true.